Hey, howdy ho, everybody. It's Mr. Allen here, and we're going to start on some inverse trig today, which sounds like it's a lot harder than regular trig, but it's not that bad. Essentially, what we're doing is before we were using trig to find missing sides, but now we're going to use it to work backwards and find missing angles. So essentially, whenever you see a little -1 over here on the top, that means we're looking at the inverse sine or the inverse cosine or the inverse tan. And all this means is that we're doing a special calculator function in order to work backwards. So if I say the sine of A equals 4.38 or 0.4384, then I say that A is equal to the inverse sine of that decimal, 84. So let's pull up our calculator and see if we can find where that is. So first, what we're going to do is we're going to look at, first we've got to make sure we're in degrees, which we are. And then next we want to pull up the inverse sine button, which is right here. It's right above the sine button. But in order to get that blue section, we go to second and sine, and then we plug in our decimal, 0.4384. Okay, 0.4384. 384. And we'll close our parentheses. And see, we got a number that's very, very close to 26. So what that tells us is that it's probably just going to be 26 degrees because the 0.4384 was rounded. And so we weren't able to ever actually get the exact number. So most of the time, in the problems that you see, you're going to get numbers that are like very, very close to some integer value. And when that's the case, you just round it to that integer. So when you look at angle B, 7/8, it's very close to 29 degrees. We can say 28.96, but for most purposes, it's basically 29. So you can figure out angle Q on your own. So let's do an example or two. So let's try each of these angle measures. So first of all, let's remember from last time, SOHCAHTOA, sine opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent is opposite over adjacent. So we're looking at angle A, so that's going to be our reference angle. Now, in a lot of these problems, there's only going to be two sides that are given to us. Now, we can use the Pythagorean theorem to find the third side whenever we know two sides. But it's pretty much just easier to stick with our integers, stick with the values that are given to us directly. So we're dealing with opposite and adjacent. So we decide, all right, am I looking at sine? Well, we don't have the hypotenuse given to us, so that wouldn't be best. So cosine wouldn't be the best either because we would have to take an extra step to calculate our hypotenuse. It's much better to use tangent because tangent, all we need is opposite over adjacent, and those are just straight up given to us. So tan of A equals 7/6. And now we'll pull out our calculator and we say A equals the inverse tan of 7/6. So let's go ahead and calculate that real quick. We want the inverse tan, so second tan, 7/6. Don't forget to close our parentheses. and that gives us 49.4 degrees. Okay, pretty cool. Yeah, it's not that hard. I think it's really not any harder than regular trig. So 49.4, we'll label that. We can do a couple of other examples. And really, you actually have enough information right now to solve the rest of these examples on your own. But just to make sure that you're understanding it, why don't you follow along with me while we solve these other ones. So we're looking at M. So we have the hypotenuse, and we have the adjacent. And we're looking, so that means we're looking at adjacent over hypotenuse, so not sine. And yeah, cosine looks like it would work pretty well because cosine is adjacent over hypotenuse. So that pretty much does everything that I want it to do. So cosine of m equals adjacent, 5, over hypotenuse, 11. And then I pull out my calculator, and I'm going to say that m equals the inverse cosine of 5 over 11. Five over 11. And we get 62.96. So it's about 63 degrees, depending on how close you want to round it. But 62.96 is great. It's mostly ideal to round to 2 decimal places with these. Okay. So in this case, we're going to practice both finding missing sides and finding missing angles, because we know that in triangles we can figure out all the sides and all the angles if you have just a few of each. So we're going to start by using the Pythagorean theorem to figure out what the value of our third side is. And then from there, we can figure out an angle based on using reverse trig. Okay. So, and it really doesn't matter which angle you start with. You could start with the angle on the upper left if you prefer. But we're just going to start at the bottom. That's totally fine. So we have opposite over hypotenuse. So that's the sine. We're going to do sine of A equals 8 over 16. And if you want to simplify that to 1/2 or 0.5, that is totally okay. But you can leave it as 8 over 16, and I think that's what we'll do when we put it into our calculator, just to avoid any confusion. So the arcsine of 8 over 16 equals, oh, that's pretty nice. It's just exactly 30. So this is something that's actually just good to know. Whenever your hypotenuse is exactly twice as long as one of your legs, then you have a 30-degree angle. And of course, we know from previous units that we can calculate the third angle just by subtracting the other two. So we do 180 minus 120 is 90 plus 30, so we get 60. So we call this a 30, 60, 90 triangle. And these kind of crop up a lot. Okay. So I am gonna let you go right now, I think, and because I think this is enough video, but you can try the other problems on your own, and we'll go over some examples in class. Good luck, everybody.